Hi everyone, good morning. Today, my name is Manya and we'll be doing the AMC-8 2024 problems and solutions. So the agenda is that we'll be doing the AMC-8 2024 problems and we can be discussing key strategies and tips to improve your score on the AMC-8. And there'll also be a question and answering session at the end where you can ask some questions and I'll try my best to answer them. Let's get started. Question number one. What is the unit digit of this number? So they're asking us to subtract this, and we need to find the unit digit, meaning the ones digit. And instead of subtracting all of this, since these differ by a whole place value, so this number is 10 times this number, and this number is 10 times as much as this number, and so on. So instead of subtracting all of this, assume that this number may be 12, because it's one number that ends with a 2 as well. 12 minus 2 for this one. And then we can do minus 2 for this one as well. And then we can subtract 2 here. We're just doing the unit digit here. Minus 2 here. And minus 2 here as well. And we started with 12 here because we don't want this number to be a negative number. We want it to be a positive number. So we just started off with 12. And 12 minus 2 is 10. 10 minus 2 is 8. 8 minus 2 is 6. 6 minus 2 is 4. And 4 minus 2 is 2. And so our final answer, or final digit, ones digit, would be 2. And that's our final answer, B. Problem number 2. What is the value of this expression in decimal form? So we need to simplify this expression and write this in a decimal form. Well, we know that to simplify that 44 over 11 is just equal to 4. 4 plus, and we also know that 110 over 44, well, if we divide by 22 on both the numerator and the denominator, we'll be getting 5 over 2 plus 44 divided by 1,100 will be simplified into 1 by 25. So this would be our final answer, but we would need to express this in decimal form. And to do this, we would just simply convert the fraction to a decimal form. So it'll be 4 plus 2.5 plus 0.04. And we can just add this, and we'll be getting 6.54. And that's how we got our answer choice C. Problem number 3. Four squares of side length 4, 7, 9, and 10 units are arranged in increasing order so that their left edges and bottom edges align. The squares alternate in color, white, gray, respectively, as shown in the figure. What is the area of the visible gray region in square units? So there's going to be two solutions for this answer. So for the first solution would be maybe we know that this whole thing is 10 by 10. The square right here is 10 by 10. So we can do 10 square minus 9 square to find the shaded region for this part right here. This one right here. We would do 10 square minus 9 square plus, in parentheses, 7 square minus 4 square. And we do this to find the area of this shaded region right here. So now we can just solve this. So 100 is 10 squared. So 100 minus 81 is 19. 19 plus 49 minus 16. So 49 minus 16 is 33. So 19 plus 33 is equal to 52. And that's our final answer, E. But now let me tell you solution B, the second solution. So for solution B, let me just move this right here. So for solution B, you can do that to find the area of this part right here. I'm highlighting this in red. This one right here, you can cut this one like that. And we know that this one, since this one is 9 units, then this one would be 1 unit, right? Because it's 10 minus 9, which is equal to 1 unit. So if this one's 1 and this one's 10, then to find the area of it, it's just going to be length times width, which is 1 times 10, which is 10. So this block right here is going to be equal to 10. This one, on the other hand, is going to be equal to 9 times 10 minus 1, because this is 1. So 9 times 1 is equal to 9. So this block over here is going to be equal to 9. So once again, we got that this shaded part right here is equal to 9 plus 10, which is equal to 19. And that's also what we got over here. Now, to find the area of this shaded region, we would do the same thing. So we would split this maybe like this, and to find the length of this part, we would do 7 minus 4, which is equal to 3. Since if this part is 7, that means that this part should also be equal to 7. So this one is 3 by 7. Since we know that this side length is 7, that means that this side length should be 7 as well. So this one's 3 times 7, which is equal to 21. Well, this one, on the other hand, this one should be equal to 4 times 3, since this side length over here is also equal to 3. 4 times 3, which is equal to 12. So this shaded region over here should be equal to 12 plus 21, which is equal to 33. So once again, we got 19 plus 33, which is equal to 52. And that's the same exact thing that we got over here as well. And so problem number 4. When Yoon-ji added all the integers from 1 to 9, she mistakenly left out a number. Her incorrect sum turned out to be a square number. Which number did Yoon-ji leave out? So by square number, they mean something like an integer times an integer, which is the same. So x times x, which is the same thing as x squared. So by that, they mean that 1 squared is equal to 1, 1 times 1. 2 squared is equal to 4, right? Because it's 2 times 2. And so on. So when she added the integers from 1 to 9, so first of all, let's add the integers from 1 to 9. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 is equal to n times n plus 1. That's just a formula which we can use to add these numbers up, divided by 2. So by this, I mean that we should do the largest value, which is 9 in this case. 9 times 9 plus 1, which is 9 times 10, by 2, which is the same thing as 90 by 2, which is equal to 45. And so 1 plus 2 plus 3 all the way up until 9, if you add them, that's going to give us 45. So now since we got to answer 45, what is the closest square number that is less than 45? That'll be 6 squared. 6 squared is less than 45. 6 squared is equal to 36, because 6 times 6 is equal to 36, and 36 is less than 45. So 45 minus 9 is equal to 36, meaning that she left out the number 9 in order to get 36. And if you were wondering why we don't do 49, since 7 squared is equal to 49, and 49 is closer to 45 than 36 is closer to 45, she said that, the problem said that she mistakenly left out a number. By that, she means that she missed a number. She didn't add that number. They didn't say that she added a number. If they said that she added a number and not left out a number, then we would probably get 49. So that's how we got to answer choice E. Problem number 5. Alia rolls a two standard six-sided dice and she notices the product of two numbers rolled is a multiple of 6. So she has two dice here and the number that she rolled is a multiple of 6. So which of these following integers cannot be the sum of the two numbers? And these are the answer choices which they mean by the following integers. So she has two dice here. And these are just a standard six-sided dice, meaning that they have the numbers 1 through 6. So maybe 1 can be here, 2, 3 here maybe, 4, 5, 6, or something like this. So now we know that this is just a standard six-sided dice. And by a multiple of 6, well, what can we do? So we know that a multiple of 6 can be including 2 times 3. 2 times 3. There can be 1 times 6. 6 times 2. 3 times 6. 4 times 6. There can also be maybe 3 times 4. And there can be like 5 times 6, and there's many more. But now we just need to add these, and we need to check which of the following integers cannot be the sum. So 2 times 3. Well, if we add 2 plus 3, that will be giving us 5. And so 5 cannot be the answer. How about 1 times 6? 1 plus 6 is equal to 7. So no. How about 2 times 6? That's going to be equal to 12, but we're going to have to add 6 plus 2, which is equal to 8. So then 8 cannot be the answer choice either. 3 times 6. 3 times 6 is equal to 18, so 3 plus 6 is equal to 9. So this cannot be the answer either. 4 times 6 is equal, 4 plus 6 is equal to 10, but 10 is not in these answer choices. 3 times 4 is equal to 7, 3 plus 4 is equal to 7, but 7 is already crossed out. And the only number that is not crossed out so far is the number 6. And we just proved by eliminating all of the other answer choices that 6 is the only number that is left here. And so that's how we got our answer choice B. Sergei skated around an ice rink, gliding along different paths. The gray lines in the figures below show 4 of the paths labeled P, Q, R, and S. What is the sorted order of the 4 paths from shortest to longest? So what is the shortest path? Well, we obviously know that the longest path is Q since it goes like this, and it will take the longest amount of time. So Q is definitely the longest, so Q should be going here. But now, if you look at it, only these 3 answer choices will be containing Q as the last place. So A and C cannot be the answer choice. Then we obviously know that path S would be the second longest here, because it goes like this. So then S should be over here. S should be over here, here, here. So now we know that E cannot be the answer choice either. And now it's between B and D. So we would have to either figure out if path P is the shortest or if path R is the shortest here. And how do we find that? Well, here we know that path R is not going around like that. And here as well, path R is not going around like that. So in this case, suppose that we have an oval here and here. And would this be better here? Or if we would go all around, would be better? Well, I think that the first option would be better, like this. Because in this case, we're not touching the outer edge right here. And so this would make it the shorter path than path P, because path P is longer than path R. And so it should be R, P, S, Q. So R, P, S, Q. So B cannot be the answer choice, and so D has to be our answer choice. Problem number 7. A 3x7 rectangle is covered without overlap by 3 shapes of tiles. 2x2, 1x4, and 1x1. Shown below. What is the minimum possible numbers of 1x1 tiles used? So we know that there is a 3 by 7 rectangle, meaning that there's 21 tiles. And there's a 2 by 2, 1 by 4, and a 1 by 1. So if there's 21 tiles, and asking what is the minimum number of 1 by 1 tiles used, then we know that this 2 by 2 square and this 1 by 4 square should be covering the majority of this grid right here. So if this one is 21, then we would have to do 21 divided by 4, since 2 by 2, 2 times 2 is equal to 4, and 1 times 4 is also equal to 4. So we should do 21 divided by 4 because once again, we want to cover the majority of this grid. So 21 divided by 4 is equal to 5, remainder 1. Then shouldn't the answer be 1? Well, we need to just double check here because we're not completely sure. So it can be 5 remainder 1. It can also be any other numbers as well. So here it can be, maybe we can do this one right here. 1. Or we can start off with this one. So 1, 2, 3 here. And we can place the 2 by 2 one right here. But now we'll be remaining with 5 squares, okay? So 5 might be our answer. Let's try to narrow it down though. So 5 question mark. And now we know that if we do 21 divided by 4, or we can do that if we subtract 4 from this, then we should be getting 4 remainder 5 maybe. Or we can get 3 remainder 9, and so on, something like this. So we can get 2 remainder 13, or something like this, right? And so this number, it cannot be 2, it cannot be 3, and it cannot be 4 either, because we cannot have a remainder of 2, 3, or 4. And so now we can try to place this in some other way. So let me just delete this. So we have 5 remaining so far, but we need to try to get 1 remaining, or we just need to try our best. So suppose that we start off by placing this over here. 1, 2, 3, and 1, 2, 3, 4 here. Okay, this is a 1 by 4 right here. And so we'll be left with 1, 2, 3, 4, 5. Once again. And if we keep doing trial and error, then we will still be left with 5. Whether you try in as many ways as possible, you'll still be left with 5. And that is at least. So you have to use 5 1 by 1 tiles used. And that's how we got our final answer, choice E. Problem number 8. On Monday, Ty has $2. Every day he either gains $3 or doubles the amount of money he had on the previous day. How many different dollar amounts could Ty have on Thursday, 3 days later? So on Monday, so I'll write M for Monday. I'll write this right here. So M for Monday. So Monday to Tuesday, Tuesday to Wednesday, and Wednesday to Thursday. And that's 3 days. They also said that it's 3 days later here. So this is 3 days. So 1 day from Monday to Tuesday, 2 days from Tuesday to Wednesday, and 3 days from Wednesday to Thursday. So 3. And they're asking how many different dollar amounts could Ty have on Thursday? And every day he either gains $3 or doubles the amount of money he had. So $2 on Monday, $2 on the first day, $2 too. Suppose that he doubles it to $4 to $4 times 2, which is $8 to $16, right? We just doubled this. But now, how about we just do $2 and double, $4 double. But now instead of doubling 8, how about we can add 3 to it? Suppose that he just gets $3 on the last day. And now we can do the same thing again. So we can go from $2 to $4. But now instead of doubling $4, how about we can add 3? We can get 7, and now we can double it. $2 to $4. We're just trying to list out every possible way. $7 and $7. Now we can add 3. How about now $2, but instead of doubling it, how about we can add 3? So $2 to $5, $5, and we can double. And we can double once again. So 20. Notice how all of these dollar amounts are all different. So we can go from $2 to $5 and then $5 and we can double it again. And now instead of doubling it again from 10, we can add 3. We should be getting 13. Now $2 to $5. Now instead of doubling it, we can add 3. So 8, and now we can double. Now, watch. We can do 2 to 5, 5 to 8, and we can do 8 to 11, right? We can just add 3. But now watch. 16 is here, and 11 is repeated as well. And we cannot repeat different dollar amounts because they're asking how many different dollar amounts could Ty have on Thursday. So we need to cross out. Maybe we can just cross out the last two since we cannot just duplicate them. They all have to be different dollar amounts. So we'll just cross out the last two. And we'll be getting, since these are all different dollar amounts, we should be getting that there's 6 different dollar amounts here. If you count them 1, 2, 3, 4, 5, 6. So that's our final answer, D. Problem number 9. All of the marbles in Maria's collection are red, green, or blue. Maria has half as many red marbles as green marbles and twice as many blue marbles as green marbles. Which of the following could be the total number of marbles in Maria's collection? So we know that Maria has half as many red marbles as green marbles and twice as many blue marbles as green marbles. So instead of writing G by 2, right here, instead of writing G by 2 because it's half as many red as green, assuming that green is G, instead of writing G by 2, let's just write G because we don't want a fraction of a marble. We'll just write G here. And if red is G, so if half is G, that means that green has to be equal to 2G. And if it's twice as many blue marbles as green marbles, then blue has to be equal to 4G. Okay, so here once again, half as many red as green. This is red right here, and green is 2G. So half of 2 is 1, so it's just G. And double the amount as 2 is 4. So this would be our expression right here. And if we add this, then we should be getting 7G. So 7G, so this answer choice has to be divisible by 7 because we don't want G to be a decimal and G has to be an integer. So one of these answer choices have to be divisible by 7. There's no other option because we can't have like half a marble here. We either have a whole marble or no marble at all. So the only answer choice that is divisible by 7 is 28. And that's how we got our answer choice E. Problem number 10. In January 1980, the Mauna Loa Observatory recorded carbon dioxide CO2 levels of 338 ppm parts per million. Over the years, the average carbon dioxide reading has increased by about 1.515 ppm each year. What is the expected CO2 level in parts per million in January 2030? Round your answer to the nearest integer. So first of all, we need to find the difference between the years from 1980 to 230. And so that'll be 2020, or sorry, 30 to 1980. And that will be 50 years. And we know that the parts per million increase by 1.515 parts per million each year. And so if we would round this to the nearest maybe tenth, then we should be getting 1.5. Okay, this is just approximate. So 1.5 times 50, since it's 50 years. And if we do that, we should be getting 75 because 1.5 times 50 is equal to 75. And so we need to add 75 to 338. And we got 338 from here. I'll draw an arrow here. 338. And if we would add this, then we should be getting 413. And this should be a final answer choice, but remember how we left out the 0.015 parts per million? If we would like add all of this together, it should be approximately adding 1 to this. So it should be 414 actually because we forgot this part. Or we didn't forget it, we just left it out to make this simple. So it should be actually equal to 414 if we round this to the nearest integer, and that's how we got our answer choice B. Problem number 11. The coordinates of triangle ABC are A, 5, 7, and B, 11, 7, and C, 3, 1, with y being greater than 7. The area of triangle ABC is 12. What is the value of y? So here, suppose that we have a grid. And now I have this random point. Maybe this can be 2, and this point can be 3. So this should be 2, 3. And here, I'm going to use here. So this point should be 2, 3. And now suppose that I move this way, and this should be 7. Then which point should change? Would the x change or the y change? This is x and this is y. So would the x coordinate change or the y coordinate change? Well, now if we do this, then the x coordinate should change. The y coordinate will stay the same. But if we go up or down, then the y coordinate would change. But if we go horizontal, left or right, then the x coordinate would change. So here, we know this right here. So suppose that this is like laid out on a grid here. Suppose that this can be the grid. Then this point would be 5, 7. This point would be 11, 7. And from here to here, this would be 5 units. Because 7 minus 2 is equal to 5. And we can do the same thing here. 11 minus 5, we got 11 here and 5 here. That would be equal to 6. So the base of this triangle is equal to 6 units. But now we need to find the area and the value of y. Y is right here. First of all, how would we find the area? Well, first of all, let's draw the height. And by height, I mean we can draw something like this. It should be touching the ground, perpendicular to the ground right there. Or it should be looking something like this. Okay, and we can just connect the dots here. Okay. Something like this. Okay? So, we have this right now. And now we can make that, we know that to find the area of the triangle, we would have to do base times height by 2. And we know that the base is 6. So 6 times height by 2. And we know that the area is already equal to 12 since I said that the area of ABC is equal to 12. So 6 times h by 2 is equal to 12. Well, if we multiply by 2 on both sides, then we should be getting 6h is equal to 24, and h is equal to 4. So the value of h is equal to 4. So height is equal to 4. Then if we know that the height is equal to 4, the height meaning this side, then would the x change or the y change? Well, we already know that if it's the right to left, then the x would change. But if it's up and down, the height, then y would change. So we will have to add 4 to 7, and we should be getting 3, 7 plus 4, which is 11. And so y would be equal to 11. And that's how we got our final answer, D. Oh yeah, I forgot to tell you, but there's another way to solve this problem as well. And since there's three coordinates right here, so 11, 7, 5, 7, and 3, 1, we can replace this. So we can do x1, y1 here, x2, y2, and x3, y3. And we can use the shoelace theorem, which is this formula right over here. And we can just solve this again, and we would still be getting the same answer, 11. But another answer that we should also be getting, since there's an absolute value sign right here, we should also be getting y equals 11 and y equals 3 as well. But now, if we reread the question, we know that y is greater than 7. And so the only possibility that y can be is y is equal to 11. Problem number 12. Rohan keeps a total of 90 guppies in 4 fish tanks. There's one more guppy in the second tank than the first tank. So first let me draw the squares right here for the fish tank. Okay, this is the first one. This can be the second one. This can be the third one, and this can be the fourth one. Something like this. So now we know that there's X number of guppies in the first tank, so X, and I'll write it here, so X. In the second tank, there's one more guppy than the first tank, so X plus 1. There are two more guppies in the third tank than the second tank, so there's two more guppies, so we don't do X plus 2 because we know that there's two more here, so we do X plus 3 because we're comparing this one to the very first one. And for the fourth one, we know that there's X plus 6 because there's 3 more than the third tank, which means that it should be X plus 3, which is X plus 6. So now we can make an equation here. We know that there's 90 guppies in total in 4 fish tanks. So we can do 90 equals X 90 equals X plus 1 plus X plus 3 plus X plus 6. And we should be getting 90 is equal to 4X plus 10. If we just add all of these up right here, so 90 is equal to 4X plus 10. 4X is equal to 80. And we should be getting, divided by 4, X is equal to 20. But that's not our final answer choice because they're asking how many guppies are in the fourth fish tank. So in the fourth fish tank, we know that in the fourth fish tank there's X plus 6, meaning that there should be 20 plus 6 guppies. And that should be giving us 26 guppies in the fourth fish tank. Problem number 13. Buzz Bunny is hopping up and down a set of stairs, one step at a time. In how many ways can Buzz start on the ground, make a sequence of 6 hops, and end up back on the ground? For example, a sequence of hops is up, up, down, down, up, down. So let's just write all the sequence of hops. Up, up, down, down, up, down, where U represents up and D represents down. Another way could be maybe up, up, down, up, down, down. We don't want to do down, 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 up, because we know that the bunny cannot go lower than the stairs. The bunny cannot go this way anymore because this is the ground level. The bunny, there's no way the bunny can go lower than that, but the bunny can go higher than that. So we must start with an up no matter what. Another way could be up, 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 down, down, down. Right? Up 3 and down 3. Another way can be up, down, up, down, down. And another way can be up, down, up, down, up, down. Is there any other way to do this? There's up, so we can move two ups, two downs, one up, and one down, which can work the first way. The second way would be moving two up, one down, one up, and two down, which can also work. The third one would be moving two up, three up and three down, which can also work. And the fourth one could be up, down, up, up, down, down, which can also work. The fifth one should be up, down, down, which can also work. Meaning that there's 5 ways to do this, and that gives our answer choice B. Problem number 14. The one-way routes connecting towns A, M, C, X, Y, and Z are shown in the figure below, not drawn to scale. The distances in kilometers along each route is marked. Traveling along these routes, what is the shortest distance from A to Z in kilometers? So let me choose a different color for this, and we can use pink. So we want the shortest route from A to Z in kilometers. And so A to M, how do we go from A to M? Well, to go from A to M, well, we can do A to M. There's 8 here, so it would take 8 kilometers. Another way could be going 5 up and 2 down, which would take 7 kilometers, which is way less than that. So 7 here. Or another way could be, how about we can just skip past M and we can go this way, which would be 15. 15 plus 17 would be giving us 32. So 32 is there, but we see that 32 is the longest way. One of the longest way possible. But we want the shortest distance, not the longest, so we can stick back to our AXM, which is 7. So 7 kilometers. 7 plus going maybe this is 14, but this is 6 plus 5, which is 11, plus we can go 10, which will be giving us 11 plus 7 plus 10, which will be 28. And we see that 28 is the shortest route possible, and that's how we got answer choice A. Problem number 15. Let the letters F, L, Y, B, U, G represent distinct digits. Suppose fly is the greatest number that satisfies the equation. 8 times fly equals bug, which means that 8 times FLY is equal to BUG. What is the value of FLY plus BUG? So we know that we want FLY to be distinct digits. So we want FLY to be like different digits. So we'll just start with maybe 1, 2, 3. And we also want it to be the largest value. So 1, 2, 3. We know that F has to start with a 1 because we can't have 2. We can't have F be 2 because if we do 2, then this will not be 6 digits, it'll be 7 digits. So that's not possible. So F has to be equal to 1. And that means that L has to be equal to 2 and Y has to be equal to 3. And so FLY times 8, if I multiply it, we should be getting 4, carry the 2 here, carry the 1 here, 9, 8, 4. We should be getting 9, 8, 4, 9, 8, 4. And these are all different digits, but they're like repeating, like BUG is works here. And FLY also works here. And so FLY plus BUG, well, we can just add them. 1, 2, 3 plus 9, 8, 4. We'll be getting 1, 107, 1107. And that's how we got to answer choice C. Does anyone have any questions on this problem or any of the problems that we talked about so far? Okay, if no one has any questions, then we'll have a 2-minute break.
Oh,
Yeah, hi.
yeah.
No.
I have I have to I have to drop off for my swimming class because I have to get ready. But
Oh, yeah.
thank you
Yeah.
for all thank you for all the help, Mania, and I'll try my best on the AMC-8. It's been a great help. Thank you so much.
Okay, thank you. There's also going to be class tomorrow, just saying.
Okay.
Please join at the same time. Thank you so
Okay.
much.
Thank you. Bye.
Bye. Okay, now break's over and we can continue by solving problem number 16. We just finished problem number 15. And yeah, we can start by problem number 16. So problem number 16 says that Min enters the numbers 1 through 81 into the cells of a 9 by 9 grid in some order. She calculates the product of the numbers in each row and column. One is the least number of rows and columns that could have a product divisible by 3. So should we start by drawing a 9 by 9 grid? Just like draw a 9 by 9 grid here. And should we like actually spend our time on this without actually first understanding the question? Well, we shouldn't. First of all, we should just start by drawing a small grid and we can make it into a bigger grid. So let's start off by drawing a 2 by 2 grid here. And we can just write some random numbers like maybe 1, 2, 3, 4. And now the product of this would be 2. The product of this number or this row should be 12. The product of this should be 3. And the product of this should be 8. Okay, so we just drew a 2 by 2 grid, which we all know that this numbers, we all know how to calculate the product of this. How about now we draw a 3 by 3 grid? So we can place like some random numbers like 1, 3, 5, 7, 6, 8, 9, here maybe 2, and we can do, what number are we missing? 4. So here I just drew a 3 by 3 grid. These numbers are like really random, and now we need to see if this row is divisible by 3 or not. Well, this number contains the number 3, so this number must be divisible by 3. So it has to be yes. This number has to be divisible by 3. Well, how about this one? This number contains a multiple of 6 or multiple of 3, which is 6 and 9. So this row must be also divisible by 3. How about this row? This row does not contain any multiples of 3. So this one is not divisible by 3. No, we don't even need to calculate. We just automatically know. How about we do this row? This column. This one is yes, because this number contains the number 6. How about this one? No, because it does not contain any multiples of 3. And this one, yes, because it contains a multiple of 3, which is 3 and 9. So, so this is what we have so far. But now, here we also know that here, these numbers are really random. But now, instead of random numbers, we can pick some special numbers here. And so we can do maybe place the first three multiples of 6 or 3, which is 3, 6, and 9 here. We could just place it in a diagonal. So this 3 would be covering this whole row and this whole column as well. This 6 will be covering this whole row and this whole column. The 9 will be covering this whole row and this whole column as well. So if we place 3, 6, 9 somewhere in a place somewhere like this, then they'll be covering the whole entire grid. No matter what numbers you place in these other spots, they'll already be covering this whole entire grid. So if we spread the numbers apart, then they'll be covering the majority of the grid. But if we look at this problem, they're asking what is the least number of rows and columns that could have a product divisible by 3. So here, what if we try to do the opposite? What if we try to compact them all together in one location? So we can do 3, maybe we can do 6 here, and maybe we can do 9 here. So in this case, 3 would be covering this one. 3 would also be covering this one. 6 would be covering here, and 9 would be covering here as well. But this square right here is empty. So this in the 3 by 3 grid, this is the least so far, but when we compact it. But if we looked at a larger grid, such as a 9 by 9 grid, we'll understand what we mean by compacting all the numbers together. So let me explain. So let me tell you this in a 9 by 9 grid. So in a 9 by 9 grid, we know that the problem, it says that it must have a product that is divisible by 3. And this is a 9 by 9 grid. But they want all the rows and the columns to have the least divisible by 3. And so how many numbers are divisible by 3 from 1 to 81? We got 81 because it's 9 times 9. So 1 to 81, there's 81 divided by 3, 27 numbers that are divisible by from 1 to 81 by 3. So 27. And by compacting them, I mean that we need to place them in a square here. And we can start by a 5 by 5 square. And we're going to try to place this in a corner so that it can take up the least amount of space, the least amount of columns, and the least amount of rows here as well. So here, let me draw a proper square here. This one. Or it should be looking something like this, okay? So we have this square. So I'm not sure if you can see it. Here, let me. Okay, so I have this color right here, which might be better to see. And now we know that we still have 2 remaining because if it's a 5 by 5 grid, then we'll have 25 squares here. So 25 squares, but we should be having 2 remaining. So 27 minus 25, which will be equal to 2. Okay, so we should have 2 remaining. But do we want to place them like this way, so x here and x here? Or do we want to do x here and x here? Well, we want to take up the least amount of space as possible. So if we go like this, then we will be covering another row and another row as well. So 2 rows. We'll be wasting 2 rows here. But we only want to do 1 row. So we'll just place this one right here. So, and we also want this one to be as compacted as together. But we can also place it here as well. And it would be the same exact thing here. It would still be column, which is the same thing. So we can place it anywhere we would like. And I'll just place it here, but it's up to you. Just place it somewhere that's really close to this square. Don't place it like in this opposite corner because we want to like minimize the amount of rows and columns that we're counting. So here we know that this is 5 rows, or sorry, 5 columns. 1 column, 2, 3, 4, 5, and this is also 5 rows. 1, 2, 3, 4, 5. But watch how we added this extra row, so this would be our 6th row. So it will be 5, plus 5 plus 6, which is equal to 11. And so that means that we have 11 rows and 11 columns. So we have 5 rows and, sorry, 5 columns and 6 rows. And if we add them up, we'll be getting 11 in total. And so if we compact them all together, then we should be getting 11. So that is a minimum rows and columns that can have a product divisible by 3. So we can go to problem number 17 now. And it says that a chess king is said to attack all of the squares one step away from it, horizontally, vertically, or diagonally. For instance, a king on the center square of a 3 by 3 grid attacks all other 8 squares as shown below. Suppose a white king and a black king are placed on different squares of a 3 by 3 grid so that they do not attack each other. And how many ways can this be done? So we have this square right here, and suppose that we have, I'll use this color, which represents white. Since if I write white here, you won't be able to see it. And maybe we can have this color that represents black. Okay, so we have two colors, and these are just the codes right there. So, suppose that we have a white king and a black king that are placed on different squares of a 3 by 3 grid. So these are all 3 by 3 grids. Suppose that I have, how about instead of the key, we just make it letters. So we'll just do that there can be this, how about there can be a white king here, or we can do a white king here, and we can place the black king maybe here, 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 and here. So there's 5 spots to place the black king here. How about we can also do that there's in an opposite corner. How about we place the white king here? We can place the black king here, 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 here. So 5 possibilities once again. The white king will have 4 corners to place, and the black king, according to that, will have 5 options, right? So it'll be 4 times 5, which is equal to 20. But wait, that's not our answer yet. Suppose that we have, how about we have maybe, we can place the white king here, and that means that the black king will have 3 options. So black king, black king, black king here. How about if we place the white king here, then the black king will still have 3 options. If the white king's here, the black king will still have 3 options. And if the white king's here, then the black king will also have 3 options. So the white king has 4 options in the 4 edges, and the black king will have 3 options to move. So without getting attacked by each other. So 4 times 3, which will be giving us 12. These are the 2 possibilities which can work, and that'll be 20 plus 12, which is equal to 32. And that's how we got our answer choice E. Problem number 18. Three concentric circles centered at O have a radii of 1, 2, and 3. Radius just multiple for radius. So 1, 2, and 3. Points B and C lie on a larger circle. The region between 2 smaller circles is shaded as in the portion of the region between the 2 larger circles bounded by the central angle BOC. So by BOC, they mean this angle right over here, as shown in the figure below. Suppose that the shaded and unshaded regions are equal. What is the measure of angle BOC in degrees? So we know that this is 1, this would be 2, and this would be 3. So the radius is 1, 2, and 3. They also said that in the problem right over here. So to find the area of this circle over here, this one over here, and this one over here, we would have to subtract the outer value minus the inner value, which is just equal to the total shaded part. We did a problem like this, or how we had to find the area of the outer area minus inner area yesterday as well. So we would do that to find the area of, suppose, this one, this shaded region, we would have to subtract this value minus the inner value. To find the middle value right there, by middle I mean this one, we can do that. We know that the radius is equal to 2, so we can do pi times r times r, which is the same thing as pi r squared. Right? Instead of writing pi times r, we just write pi times r squared. And if we would multiply that, then we should be getting pi times 2 squared, since we know that the mid value is equal to 2. So pi times 2 squared is equal to 4 pi. So we would have to subtract this value minus the inner value. To find the value of the inner part, we would have to do pi times 1 squared. Since they told us the value of that is 1, pi times 1 squared is equal to pi. So we would be getting 4 pi. So 4 pi minus pi is equal to 3 pi. So the value of this shaded region right here, I'll just draw an arrow here, is equal to 3 pi. And the value of the center part is equal to pi. And so we know that the value of the outer part over here, to find the value of that, we have to do the same process again. And for that, we would have to do pi times 3 squared, since we know that the value of that is equal to 3. So pi times 3 squared is equal to 9 pi. But we would have to subtract that from the inner and the middle value. But we already know that this circle is 4 pi. So this whole part is 4 pi. So that'll be giving us 9 pi minus 4 pi, which will be giving us 5 pi. So that means that the value of just the outer part is equal to 5 pi. So in this case, we would have to split up the 5 pi since a fraction of this part is shaded and a fraction of this is unshaded. We have to give some part to this and some part to this one as well. But how do we split it? Suppose that we gave maybe 2 pi to this one, and how about we gave 3 pi to this one? The value of this would be 5 pi, and the value of this would be 4, which are not equal. And we know that they have to be equal because they said that suppose the shaded and unshaded regions are equal in area. So that means that they must have the same exact area. So if in this case, suppose that we gave 2 pi to this one and 3 pi to this one, then it'll be 5 times 4 again. How about 3 pi to this one? Or how about we give 4 pi to this one and 1 pi to this one? This would be 4 pi to 5 pi, which is not equal. So that means that we must give 1.5 pi to this one and 3.5 to this one, right in between. So that means that 4.5 pi must be equal to 4.5 pi, which is true, which is equal. And so that would make sense. So now we know that what is the measure of angle BOC in degrees. So what is the total area of the outer part? So the shaded area is 1.5 pi. We gave that. So 1.5 over 5 pi is equal to 3 by 10. Multiply the numerator and the denominator by 2. So we'll be getting 3 by 10. 3 by 10 here. And then we have to do 3 by 10 of 360, since we know that there's 360 degrees in a circle. And to solve this, we can divide by 10 and times 3, which will be giving us 36 times 3, which is equal to 108. So that means that the measure of BOC is equal to 108 degrees. And that's how we got our answer choice A. Does anyone have any questions on this problem? Okay. So we can go to problem number 19. Jordan owns 15 pairs of sneakers. 3/5 of the pairs are red, and the rest of them are white. 2/3 of the pairs are high top, and the rest are low top. The red high top sneakers make a fraction of the collection. What is the least possible value of this fraction? So Jordan owns 15 pairs of sneakers. And we know that 3/5 of them are red and the rest are white. So what is 3/5 of 15? So 3 by 5 of 15 is equal to 9. And we can also make a diagram here, just make a rectangle over here. And we can split this one into 5 parts. So 1, 2, 3, 4, 5. And if we do that, we can represent each of the values as x. And we know that the total must be equal to 15. And when we divide this into 5 parts, and here, we know that the total value must be equal to 15, and that means that each part of these should be equal to 3, and 3/5 of that is equal to 9. Once again, so it's still going to be equal to 9. So we know that there's 9 red. So here, I'll write 9 red, 9 red, and there's going to be 6 white. Because it's 15 minus 9, which is going to be equal to 6. So 9 red and 6 white. And we know that 2/3 of the pairs, so 2/3 of the pairs, 2 by 3 of 15 is equal to 15 divided by 3 times 2, which is equal to 10. So 2/3 of 15 is equal to 10. So 10 must be high top, and 5 must be low top. Okay, this makes sense. And they want the red high top sneakers to make the least value of the total. So we can place all of the 6 high top. So there can be 6 white high top. And there's gonna be 10 minus 6, which means that there should be 4 red high top, right? Here we know that there's 6 white high top out of the 10, and there's still 4 remaining. So the 4 high top must be red. So there must be 4 by 15. 15 is the total, and 4 of them are red high top. And this would be our fraction and our answer choice C. Problem number 20. Any 3 vertices of the cube P, Q, R, S, T, U, V, W shown in the figure below can be connected to form a triangle. For example, vertices P, Q, R can be connected to form an isosceles triangle PQR. So by that I mean PQR can be connected to form an isosceles triangle PQR. And we know this because, here, let me use this one. So P, Q, and QR are equal to each other. But PR is not equal to any of those two. Oh, here. So this cannot work. So we need to make these triangles equilateral. And whenever we draw here, this may not look equilateral since we see the cube like this. But if we tilt it, if you have a cube at home, you can maybe try to draw this on the cube, or you can just try to visualize this. So these triangles over here that we draw will not look equilateral, but they in fact are if we think about it. So let's see. We have P to T on here. P to T, right? This is the diagonal. And then we have T to R, and then R to P. This length right here may not look equilateral since we're looking at the inside of the cube. But if we try to visualize that, we know that if we like change the angle of the cube, this would be equilateral. Since from T to R and T to P should be the same or should be similar. And then we also have suppose that we can go from T to we can go from T to P, and then we can go from T to V, and then we can go from V to T. This, if you try your best to visualize it, it should be looking equal out. Here, let me choose a different color. That's confusing. Here, okay. So P to T, T to V, and V to P. If you try to visualize it, it should be looking equilateral pretty much. And another way to do this is we can go from P to R to V to P. Now this looks like an equilateral triangle. We don't even need to visualize this. This looks very much like an equilateral triangle. So if we draw this, I think the hardest one would be this one right over here, the blue one over here from P to T to R. And don't get confused with an isosceles triangle and equilateral triangle since, here, let me give you an example. Since a triangle like this would be an equilateral triangle with all of the side lengths the same. This triangle over here would be an isosceles triangle with all of these side lengths the same, and this one different. And a scalene triangle is all of the side lengths different, so something like this, okay? This is a scalene triangle. Okay. So our final answer is 3 because there's 3 different ways to get equilateral triangles and contain P as a vertex, like a corner. Problem number 21. A group of frogs called an army is living in a tree. A frog turns green when in the shade and turns yellow when in the sun. Initially, the ratio of green to yellow frogs was 3 to 1. Then 3 green frogs moved to the sunny side and 5 yellow frogs moved to the shady side. Now the ratio is 4 to 1. What is the difference between the number of green frogs and yellow frogs now? So initially we had 5 yellow frogs. And if they want to move to the shady side, then first of all, they have to be there. We can't just like move something that's not there to another part. It has to be there. So we need to start off with 5 yellow frogs in the shady side. And then we move those 5 into the sunny side. And the sunny side must be 3 to 1. So the ratio should be 3 to 1. And so that would be 5 to 15. But then if we add 2 here and if we subtract here, since it should be this one we subtract 3, but we have to add 5, and this one we subtract 5, but we have to add 3, it should be looking something like this, which is equal to 17 by 3. But this is not in the ratio of 4 to 1. So it has to be in the ratio of 4 to 1, which is not true. So this one cannot be our answer. How about we go to 6. So suppose that there's 6 yellow frogs in the shady side. So 6 to 18, which is 3 to 1, and we have to add 2 to it, which is 20. We have to subtract 2. We have to subtract 2 here, which is 4. So 20 to 4, which is in the ratio of 5 to 1, not 4 to 1. So this cannot work. How about 7? 7 to 21. Well, now if we add 2 here, we should be getting 23. We subtract 2 here, we should be getting 5. So 23 to 5 is not in the ratio of 4 to 1. So this cannot work. How about 8? 8 to 24 and 26 to 6. No. How about we can go 9? 9 to 23, sorry, 27 to 29 to 7. No, that's not in the ratio 4 to 1. It's very close, but it's not. How about 10? 10 to 30. And now we can go from 32 to 8. This is in the ratio 4 to 1. And so this will be our answer. But then they're asking us, what is the difference between the number of green frogs and the yellow frogs now? So we will have to do 32 minus 8, which is equal to 24. And that's how we got our answer choice E. Problem number 22. A roll of tape is 4 inches in diameter and is wrapped around a ring that is 2 inches in diameter. A cross-section of the tape is shown in the figure below, and the tape is 0.015 inches thick. If the tape is completely unrolled, approximately how long would it be? Round your answer to the nearest 100 inches. So if the tape is fully unrolled, it should be looking in something like a straight line. Okay, so the tape wouldn't be looking something like this. It would actually be looking in a straight line. If we were to stretch it, just keep stretching it, it should be in a straight line. So now we know that this length is 2 inches thick. So half of this would be the midpoint, and this one would be 1 inch thick. But if this is the midpoint, then this whole entire thing would be 2 inches. Meaning that this is once again something that we would have to find the area, the shaded area. And to do that, we would have to subtract the outer circle minus the inner circle. The area of the outer circle would be pi times 2 squared, which is equal to 4 pi minus the inner circle, which is pi times 1 squared, which is just equal to pi times 1, which is equal to pi. So 4 pi minus pi is equal to 3 pi. And so the area of this shaded region over here is equal to 3 pi. But now we know that we have to do 3 pi divided by 0.015. And we do this because we need to find the total length of this. We need to find the total length of this. So how many of this 0.015 would fit into 3 pi? 3 pi is approximately equal to 9, but it can also be equal to 10, so between 9 and 10. Let's just write 10 because 10 is just easier to work with. So 10 by 0.015. If we do this, then we would be getting, if we multiply this by 1,000, we'll be getting 10,000 by 15, which is approximately equal to 600. Approximately. And so, our closest answer to 600 would just be equal to B. And so we can go to problem number 23 now. So problem number 23 is kind of like where we have to visualize this, and yeah, we need to try to shrink these numbers down lower. And so yeah, let's get started. Problem number 23. Rodrigo has a very large piece of graph paper. First, he draws a line segment connecting point 0, 4 and point 2, 0, and colors 4 cells whose interiors intersect the segment, as shown below. Next, Rodrigo draws a line segment connecting point 2,300 to point 5,800. He has a really large piece of graph paper. And again, he colors the cells whose interiors intersect the segment. How many cells will he color this time? So whatever they're saying is that they have this line over here, and they're just coloring all the squares that go like that, that touch this line over here. So if the line would be looking something like this, then they would color this one and this one. Okay? The line would be looking something like, or if the line would be looking something like this, even if it touches a little bit, they would still color that one. So this one, this one, this one, this one, this one, and this one. Okay? So now we know that they have these points right over here. Okay? And so instead of using all of these, how about we can shrink it by 1,000? Since all of these have 3 zeros at the end, we can shrink this by 1,000, and then we can multiply that final answer by 1,000 again, since all of these answer choices are in the thousands. So we'll be getting 2, 3, and 5, 8. So to go from x2 to y to x5, we need 3. And to go from y3 to y8, we should be getting 5. So we need to move 3 right and 5 up. So we move 3 right, so 3 right here, and 5 up. So our point should be located somewhere, 1, 2, 3, 4, 5. Should be located somewhere over here. But now the problem is that we need to draw a straight line from here to here. And we just got 3, 5 because this is the slope and we need to start from the center point. So we need to draw a straight line. So we can draw from here to here. Okay? Somewhere like this. Now, the problem is that we need to color up all of the squares here. So it intersects 1 square, 2 square. Now this square is a bit hard, but if you zoom in closer, you will see that it also intersects this square. So 3, 3, 4, 5. You can see that that small line over there, it still intersects 3, or sorry, 1, 2, 3, 4, 5, 6, and 7. So it intersects 7 squares so far. So since we know that it intersects 7 so far, you have to multiply this by 7. We would have to do 7 times 1,000, because remember how we divided by 1,000 in the beginning, but we still have to multiply by 1,000. So we would do 7 times 1,000, which is equal to 7,000. Okay, and that's how we got our answer choice C. Problem number 24. Jean made a piece of stained glass art in the shape of 2 mountains, as shown in the figure below. One mountain peak is 8 feet high, and the other peak is 12 feet high. Each peak forms at a 90-degree angle, and the straight sides of the mountains form 45 degrees one with the ground. The artwork has an area of 183 square feet, and the side of the mountains meet at an intersection point near the center of the artwork, h feet above the ground. What is the value of h? Well, how do you find this? So, to find this, well, first we need to understand something. So, we have an isosceles triangle, okay? And an isosceles triangle means it has 2 of the same side lengths. So, suppose that this is an isosceles triangle. And the angle of this is 45 degrees, so 45 degrees here. Meaning that this one should also be equal to 45 degrees, and this one is equal to 90 degrees, because this is a right angle. And suppose that the value of this is 5, and the value of this is also equal to 5 here. Okay? So this one is equal to 5 and this one's also equal to 5. Well, what is the value of this? We know that a squared plus b squared is equal to c squared, meaning that this one should be equal to 25 squared plus 25 squared, which is equal to a squared. Here, let me just do this right here. A squared plus b squared is equal to c squared. Y squared is equal to c squared. And then we'll be getting 50 is equal to c squared. And now to find the value of c, we have to divide that by the square root sign. And we should be getting c is equal to the square root of 50. But now to solve the square root of 50, we know that 50 is made out of 2 square roots. So we can do that c is equal to the square root of 25 times the square root of 2. So that means that c is equal to 5 square root 2. Since the square root of 25 is expressed as 5. So c is equal to 5 square root 2. So 5 square root 2. Now we can apply the same thing for this shape right here. So we use this triangle because there's not a formula to calculate the area of a mountain, since in real life we wouldn't use it. Well, I mean, in this case for this problem in real life we would use it because we know that this problem uses triangles. But in real life, for like a real life mountain, we know that the mountains are really like sharp and they have like really bumpy edges. And so we would have to find the area of each triangle, but instead of that, we could just use a big triangle and just approximate the area of the mountain. So that will still be using triangles. So in this case, we know that this side length is 12 and this side length is also 12 based on the dotted line. What is the area of this? Well, this one would be equal to 12 square root 2. The same thing applies for this 8 over here as well. This one's 8, this one's also 8. Then what is the area over here? This one's 8 square root 2. Meaning that this one is also 8 square root 2. And this one is also 12 square root 2. Here. Root 2. Now, we need to calculate the area of this. So, to find the area of this, then we would have to do 12. So, just of this area right here, we would have to do, you know that it's base times height by 2. We can do 12 times the square root of 2 times 12 square root 2. Sorry, there's no times here. We can just make it like that, okay? Divided by 2. And we'll be getting the whole thing divided by 2. And we'll be getting 288, since 12 times 12 is equal to 144. And the square root of 2 times the square root of 2 is equal to 2. 288 divided by 2, which is equal to 100, is equal to 144. So the area of this is equal to 144. And the same thing applies for 8 square root of 2 times 8 square root of 2, which is going to be equal to 64. Okay, and now we can add 64 plus 144, and if we add both of them up, then we will be getting 208. Now, we have a problem here. They said that the whole entire thing is 183 square feet, but we got 208. But now, if we observe this picture closely, we see that we overcounted this area right here, since this area overlaps both of the triangles. So this area over here will be equal to 208 minus 183, which is equal to 25. Okay, so the area of this is equal to 25. So here, let me create this picture right here. So this one is equal to 25. So half of that would be equal to 12.5. So half of that would be equal to 12.5. 12.5. So we got h squared by 2 is equal to 12.5. Since we got h times h, this is h and this is h, divided by 2 is equal to 12.5. So now we can multiply by 2 on both sides, and we'll be getting h squared is equal to 25, and h is equal to 5. So, and h represents the height. So that the height is equal to 5, and that's just what they're asking for. What is the value of h? H is equal to 5. And that's how we got our answer choice B. Okay, problem number 25. A small airplane has 4 rows of seats with 3 seats in each row. 8 passengers have boarded the plane and are distributed randomly among the seats. A married couple is next to board. What is the probability that there will be 2 adjacent seats in the same row for the couple? So we know that this airplane has 4 rows with 12 seats in each row. So for both of the people to sit next to each other, we know that there's 12 seats in the starting, and then after someone sat down, there's 12 times 11. So this would be equal to 132. So 132 possibilities, right? So 132 should be the denominator. And the numerator, since 132 is a total, 100, there should be the numerator. And the numerator would be equal to, since we know that there's going to be 8 passengers here, and the 8 passengers have already seated, but then we have to multiply by 10. And we would have to multiply by 10 since we know that the couple can swap spots with each other, and also the people could just swap spots with just the people right next to each other. Like if the couple would sit here, X and Y, then if they would swap places here, then they would still be next to each other. And so we would have to multiply by 10. Since there's 8 passengers and there's also 2 more people because of the couple, and we would do 8 times 10, which is equal to 80. So 80 by 132, if we would simplify that, then we should be getting 20 by 33 if we divide by 4. Which is equal to 20 by 33, and that's how we got our answer choice C. Does anyone have any questions?